Welcome to Gravity Matters Behind the Scenes. We have with us today Devarshi Choudhury, who is a PhD candidate at the Anton Pannekoek Institute of Astronomy at the University of Amsterdam. Before pursuing his PhD, he did his MSc in Astronomy and Astrophysics at the University of Amsterdam. He is also a member of NASA's NICER Neutron Star Composition Explorer Science Working Group. For our young viewers, I would like to mention that NICER stands for the Neutron Star Interior Composition Explorer, and it is an international space station payload devoted to the studying of neutron stars through soft X-ray timing. The current topic of his research is understanding the equation of state of neutron stars via pulse profile modeling of NICER X-ray data. Welcome, Devarshi.
Glad to be here. Thank you for having me.
Yes. So, the very first question that I would like to ask you is that what drove you to pursue astronomy, to pursue astrophysics as a research career?
Well, I have been interested in astronomy and space-related topics pretty much from a very early childhood. I had luckily a nurturing environment for curiosity, and my family would encourage acquiring knowledge and asking questions. And my grandfather, he would give me encyclopedia, and I would look at the pretty pictures of planetary systems and galaxies and so on. So that was where my interest originally began. But of course, that's not what caters you to a research career. As I grew older, I got more and more interested in the subjects because of TV shows and books. But then it was really during my bachelor's that I started understanding the subject. I would do various online and offline courses to understand what are the different subtopics within astronomy, within space exploration. This was also at a time when ISRO's successes were really coming about in the 21st century. So you would also hear your peers and other people in the public talk about these, and you would realize that there's the importance of this in society. So that's how I got. That's how I really focused towards this subject. As for research, within my bachelor's, I had done a project on spectral classification of classical BE stars, followed by another project at TIFR on pre-main sequence stars. These are young stellar objects before they start burning hydrogen into helium. And that was actually when I got a taste of research. So it's not just all the pretty pictures that you see in books. There's actually a lot of hard work. And so you have to dedicate time and patience to it. But then after I got this taste, I was like, it is hard, no doubt, but it is definitely also very enjoyable. It is worth taking these risks. So that's when I really actually set out towards my research career. And then I came outside abroad for a master's, and I really started to hone in on the different aspects of research that I could then pursue. Like you've got theory and observations, you've got simulation and modeling and so on. So I'm still exploring all of these things as part of my PhD, as during my master's as well, and beyond. So this is how I really came about my astrophysics research career, and I hope to continue in it.
Yes, we definitely look forward to more of your, published articles as well. Okay, so what hardships did you go through while being in your, while doing your research?
Right. So, research can often get quite difficult. As I mentioned, there are periods where you are suddenly faced with really difficult challenges, really perplexing problems. And when you come across these things, I think one of the most difficult things during times like these is that you have to remember that these are you're working in the frontier of science, and so the problems are indeed hard, and it's not you who is dumb, because that's it's very easy to fall into the trap, develop imposter syndrome, where you start feeling that, oh, it's me, I am the stupid one here, and therefore I'm not being able to solve this problem. Anyone else probably would have if they were in my position. Maybe I'm slower than others. You start really doubting yourself. It can often be very difficult to get yourself out of this kind of a trap. And the more you think about these kind of things, you really start getting demotivated, which in turn affects your work, which like it almost becomes cyclic in some senses. So in this kind of situation, you really want to have good friends, colleagues, seniors, your advisors to really chime in, remind you that, you know what, everyone goes through these things. You're not alone. We all battle through this daily. So just keep at it, and you'll ultimately overcome these things. So this is, I think, one of the biggest hardships that I face on a day-to-day basis. It's always a work in progress to realize that, yeah, you just have to keep at it. Other than this, on a personal note, I suppose it was difficult sort of navigating into research. So I came from a small town, relatively small town in India, which is now growing much more, in Shiliguri in West Bengal. And I only had proper exposure to the different research avenues once I moved to my undergrad in Bangalore. Now it was difficult already that with like in Bangalore you've got a triple major system. So I did my bachelor's in like physics, mathematics, and electronics. So it's like you're dedicating 1/3 of your bachelor's time to physics. So there's not really a whole lot of scope to do dedicated research in it. So I had to make time outside of it. But I was blessed being in Bangalore that there are so many research institutes there, like the Indian Institute of Astrophysics, Raman Research Institute, IISc, ICT, and so on. And particularly IIA, the Indian Institute of Astrophysics, being close to my campus, I got the opportunity to like go in between classes, attend public lectures, and so on, and get an idea of what it's like. But even then, it's like so you have to dedicate this kind of an extra hours to understanding what the subject is like, what the scope of research is. And after that, after my bachelor's, I wanted to continue on a research career. So I wanted to get more experience before really diving deep into it. And I mean the traditional Indian career pathways are catered more towards like job seeking to make you eligible for a job as quickly as possible. So gap years are not something that's really encouraged in Indian societies, I feel. And so there was this kind of a pressure from my environment that, you know, you should be cautious with these things because these might endanger your chances of getting a job. You might be questioned in interviews. Why did you take a gap year and so on? So that kind of really adds on to the stress that you're already going through, trying to figure out where you want to go next. And I was also seeking to apply abroad. So I had taken this gap year. But luckily, my family was very supportive. They were like, yeah, as long as you know what you're doing, we trust you. And so, yeah, go for it. And I'm glad that I did because I had a really good experience at doing the project with Professor Manoj Puravankara and Dr. Blesson Matthew at the FR. And then eventually I got admission into the University of Amsterdam. So yeah, it worked out for well, but these were certainly very hard things to deal with at the moment.
Could you share your biggest learning in the course of research? What has been your learning like? Apart from
Mhm.
that, you said that there's a constant. You need to have a constant reminder that you're not just the only one who who is going through this. Apart from this, any insight that you want to share?
Right. So, I mean, I already touched upon how imposter syndrome can be such a thing, right? So that kind of relates to another big learning that I had to soak up over time is that you have to be patient in research, because I mean, as I said, you will face these kind of challenges, which can slow you down. But beside this, even if you put in a consistent effort, and even if you're delivering, the results won't necessarily always appear overnight. It might take months before you get something that you can really defend, you can and is worth publishing. You might also encounter different kinds of rabbit holes as you come across research, because you're literally at the edge of the unknown for of us as a species. You're discovering this kind of an edge. And so while you're trying to solve a problem, you have this kind of a plan, a framework that, okay, I need to do this, this, and this, and that will get to my results. But in one of the middle steps, you realize, oh, wait, in order to perform this step, I need to know these other things, or these other questions need to be answered. And so, okay, let's see how to do that. And then you try to do that, and you figure, oh, there are more open questions that are linked to this that you have to account for, that affect your original plan. So these kind of situations occur quite often, and they can really, really delay your plans in some cases. In some cases, you'll also find researchers finding these other open problems sometimes more interesting than what they started out with and entirely change their plans. So you have to have patience in these regards, and you also have to account for like you have to make room for error in your planning.
So
Like you can't
here's where accidental discoveries also, the chances of having
exactly.
accidental discoveries are possible, right?
Exactly. So the research problem is not something that it's predefined from the beginning. It's something that you set out with a plan, but then it evolves and it morphs as you go along. So you have to account for these kind of steps. It can be often frustrating initially that, oh, like what, these additional things are taking so much of my time. I need to get to this. I need to get published. But then this is also like an interesting part of research that you should try and enjoy. Yeah, and then there's of course going to be other things like you encounter bugs in your code and just trivial issues that will delay results. So having patience, I think, is a key. And like aside from this, I think another aspect which is quite important is to like sort of have diligence and like you have to be consistent in your efforts. I've come to realize that it's easier, it's better overall for my mental health to have like a daily work life routine and be consistent in my efforts instead of um like keeping the problems for future me, and then my future self is cursing my past self, and why do I have so many backlogs now? I'm stressing out over all of these things. So yeah, I mean, now this consistent effort can also vary from day to day, from week to week. Sometimes you'll have high bursts of productivity, low bursts of productivity, but the key is that you keep on trying and keep on making incremental progress over time. So I think these are some of the main learnings which I'm still actively trying to incorporate in my life. But it's always a work in progress. Another thing that I would like to touch upon, especially having come to having worked in a research institute in the Netherlands, and I guess in Europe in general, is the focus on work-life balance that they have here. I've noticed that like when people around me in my research environment, when they work, they're really focused on working, but then they also really dedicate time to relaxing and like switching off your mind so that you can come back and freshly tackle that problem. In fact, when I first took my holidays, my supervisor was very adamant, you better not look at your laptop during this period.
That
And that was great because when I came back, I was much more refreshed. Yeah.
Okay, so is it not that your mind goes back if you're into you're researching something, that is it not that during that time also your mind goes back to that problem that that's what I came upon? I mean, how do you tackle this? I mean, if that occurs, right? Because you try
Yes.
to stop, but then somehow your mind is into that. So how do you
Yeah.
manage
Right. Well, I mean, I think it has to be a bit of an organic process. Like, if it's something that you really like, if it is drawing your mental energy in that direction, you really want to think about it, or just in your free time, you're talking to maybe science colleagues of yours in a holiday, maybe you're out with some friends from the department. In those situations, I think it can be exciting, and in fact, it helps address some problems you would not even be able to address when you're working. So I think in that regard, it can be useful. But if you notice that you're doing these tasks because you're feeling pressurized, that like, oh, maybe I should just check what the updates are, and then maybe I can contribute. Like, if you're needlessly panicking that you need to work, and it's at the end of the day it's not giving you joy, but rather taking away time from your holidays, from a time where you can really enjoy yourself, then I think that's where you have to sort of distinguish it. So you have to let it you have to kind of go with the flow in this regards. Now, I understand also this is something that really varies from institute to institute, what the work culture is like, but you have to try and do this the best you can in your environment.
Okay, thank you for this. I would like to ask you something about your research topic, and in a more general way for the younger audience.
Mhm.
As you know, while I was also reading about this, I think I came across this as a very fascinating one. That what exactly it is like, what exactly is nicer, and how because it has been launched in 2017, if I'm not wrong, right?
Yes.
Yes. So, can you please throw a little bit of light on this for the younger audience? Very general way, in a very
Right.
general and exciting, of course, because that's how the younger audience look at it.
Mhm. Yeah, so NICER is like an X-ray space telescope, and as you mentioned, it's aboard the International Space Station. And the goal of NICER is to observe, as the name suggests, neutron stars, and the intention is to study the interiors. Now, why would we want to study the interiors of neutron stars? So, to give a small background, neutron stars are these remnants of massive stars once they've undergone a supernova explosion, provided they don't form a black hole. So you end up with these objects that have a diameter about the size of a city like Bangalore or Amsterdam, where I am, but they weigh almost like twice the mass of the sun. So they are some of the densest observable objects, if you don't count black holes as being directly observable because of its singularity, then they are the densest objects we can observe at the present universe. And to give a fun fact, it's like if you take like a sugar cube of neutron star material, that would weigh as much as the entire human population or like Mount Everest. So it's really a mystery how these dense objects can sustain themselves. It's like this final form of defense from unending gravitational collapse. So our theories sort of can only predict so far into as we go into the neutron star what the nature of matter is like in such conditions. In fact, these conditions are so extreme that like electrons merge with protons, they get increasingly neutron rich. That's why the name neutron star. And but the pressure can even get so high that nuclei start fusing into blobs. So they're often called in literature as meatballs, or they can form like long structures called spaghetti or noodles, or like sheet-like structures called lasagna. So in combination, it's called nuclear pasta, and I think that's quite entertaining. But then if you go deeper still, our theoretical predictions kind of break down. Like there's the errors in our theories, they widen up so much that various different kinds of states of matter could possibly explain the structure. So you could have classical hadronic matter, or you could end up with like quarks, like the neutrons and protons dissociating into their individual quarks, into deconfined quarks, and they can even rearrange themselves into more exotic states that you wouldn't see elsewhere. So this is the kind of question we are trying to answer. And this is also interesting, not just to study neutron stars as an object, but also to understand how matter behaves, and how matter behaved, let's say, in the early universe, when the entire universe was contained in a very tiny portion. So you have these similar densities, although the temperatures would be different. So the way we try to get to this is we study the X-rays that are coming from the surface. And the X-ray, and we use a technique called pulse profile modeling. This is the trailblazing technique that was made for like catered to the NICER mission. And what you do is, as light from the surface, they emit as they emit from the surface, they sort of bend around because of this strong gravity before they reach us. So we try to model the neutron star and this gravitational effect, and we also have to come up with this like an emission surface map, and then we try to compare it with the data, and we draw inferences regarding what the mass and radius is, and the mass and radius in particular are very strongly correlated to the interior structures. So this is what we're trying to achieve, and this is really exciting to address. And there's so many open questions when we try to do this.
Okay. So apart from research, what hobbies do you share?
Right. Well, I think my biggest hobby has to be in the field of amateur photography. And me and a friend of mine, Sumedha Biswas, she's another PhD candidate at Radboud University, and there's even a Gravity Matters blog interview with her. So please go check it out for those watching this. Both of us, we collaborate, and we run this Instagram page called Cosmic Latte, and we sort of come up with different kinds of themes to photograph on and like perform edits. So that's one of the most one of the bigger hobbies of mine. Beside this, I think on a day-to-day basis, there's gaming. I suppose that's something that I indulge in. I had given up on gaming since I had started my undergrad, but then because of COVID, I've gotten back to it these days. And yeah, I'm also exploring other new hobbies. I'm trying to make room for newer things, get better with my time management. I recently started roller skating a bit. I can just barely skate. I am really weak at braking. I feel that's a crucial step in order to skate. So it's like I'm still very wobbly, but it's exciting. It's thrilling. So
And
yeah, I'm trying to indulge in different things.
okay,
Yeah.
so another question: as a science graduate, how would you like to contribute to the science community?
Right. So by the science community, if you're referring to more of those who are scientifically inclined, maybe they've started their bachelor's. In these cases, I think um, like I've particularly participated in workshops to teach certain astrophysical softwares for them to analyze spectra and so on. So that's to give them a hands-on experience of what it's like to work with astrophysical data, to be in this field. So that's something that was quite interesting. I want to get involved more in like science communications and outreach, but I have to make the time for it, to be honest. But I've personally benefited a lot from like just even watching YouTube videos on like a physics, like a vlog in the life of a physicist, or things like explainer videos by PBS Spacetime and Kurzgesagt. Aside from this, there's also like the social media, like academic Twitter and Instagram and so on, where you get like the latest news of different kinds of in different fields of astronomy. So these really can help you get a feel for the subject and get more in touch with it. Beside from this, for the general public, even outreach, I think is really important. I've joined the outreach council for our institute from the coming September, and we will be arranging different like side work, what we call side work astronomy. So we just end up at a busy location, which and we plant our telescopes, we show them the moon, we show them Jupiter and Mars to really get them excited about all of these things. So I think these efforts can really help culminate a more scientifically literate society and just have a general appreciation for the kind of effort that goes into these things, and also encourage them to take it up themselves, maybe.
Absolutely correct. I mean, that can increase the scientific temperament between the generations also to come. So,
Mhm.
thank you so much for this, for your time over here.